Good morning, everyone, and thank you for joining us for the weekly briefing on the University of Arizona campus reentry. I'm Holly Jensen, Vice President of Communications for the university. We have a packed lineup for you today. As always, with us is Dr. Robert C. Robbins, President of the University of Arizona. We also have his trusty sidekick, Dr. Richard Carmona, 17th Surgeon General of the United States and Distinguished Professor here at the university. We have asked Dr. Mike Warraby, Head of Ecology and Evolutionary Biology here at the university, to join us to discuss the new testing protocols we are rolling out this spring and give a brief demonstration so everybody can understand what to expect when they return. We have also asked Dr. Deepta Bhattacharya, Associate Professor of Immunobiology here, to join us today to discuss the science behind the vaccines the U.S. will be distributing around the country and within our local community. As always, we will take your questions at the end of the briefing. Please make sure to raise your hand and type your name and news organization into the window so that we can call on you in the order they were received. With that, I'll turn it over to you, President Robbins.
Thank you, Holly, and good morning, everyone. Thank you for joining us. I'm very much looking forward to working with Dr. Bhattacharya about the virus and vaccines, as well as Dr. Warraby about his work on a new test. I just have to digress for a moment and say that Deepta and I worked together at Stanford, and I knew he was going to be really great one day. I just didn't know how great he was going to be. He's going to talk about the vaccine today, but he and Yanko and their entire team, the work that they did for rapidly developing an antibody test, and a recent publication he had, and Dr. Warraby's upcoming publication on the really groundbreaking and novel work that he's doing, should give all Wildcats around the world great pride at the incredible scientists, clinicians, and public health experts that have come together as one team at the University of Arizona to help get us through this semester. I also want to thank the faculty, the staff, the students, and all of our partners for their efforts that have allowed us to have a successful fall semester despite the challenges posed by COVID-19. Our test, trace, and treat protocol in partnership with PIMA County and the city of Tucson were at the heart of this success. As Will Humble, Executive Director for the Arizona Public Health Association and former Director of the Arizona Department of Health Services, said in a recent story from the Cronkite News at ASU, and I quote, "Off-campus behavior has a direct impact on the success of the whole reentry program. That's why it's so key to have a partnership between the school and the city." And I would say a close partnership with the city of Tucson and the PIMA County, particularly Dr. Cullen and Chuck Huckleberry and the supervisors, has been absolutely essential. He actually will praise our efforts at being particularly effective. This work has been led in part by Julie Katzel from our Community Relations Office under Julie's incredible leadership. For those of you who don't know Julie, she is out in the community every day working really hard. Under her leadership, we've pursued a layered approach, including preemptive messaging to communicate public health best practices, proactive outreach in collaboration with the city and our neighborhood groups. As you all know, the neighborhood groups are very strong in Tucson, and we've enjoyed a great relationship with them. Responsive enforcement through the campus area response team, and using university accountability mechanisms through the Dean of Students Office and Student Code of Conduct. I think all of these measures have been particularly successful in mitigating what could have been much worse for us and helping us get through a successful semester. We will continue these collaborative efforts in the spring, and I want to thank Julie and her team, as well as our partners, for their dedication and positive impact. When the spring semester begins, we also intend to use an enhanced version of the test, trace, and treat protocol. This will include required weekly COVID testing for all students residing in our dorms, as well as all students attending in-person classes on the main campus. Any student visiting campus to access other services will be expected to have a university diagnostic test within the previous week. Compliance will be managed through access to the university's based Wi-Fi network. Students who do not fulfill testing requirements and expectations will not have access until they comply with testing or received an approved exemption. Using Wi-Fi access for compliance provides an effective way to focus enforcement. Network access is generally necessary to participate in the activities that bring students to campus, such as taking classes, while those students who are not subject to testing requirements because they're not on campus will not be affected by this measure. We think this is an incentive for people to comply with our mandatory testing. And we think it's really going to be important. And we're changing our approach because we're going to be able to expand our testing capability. And I'm very happy about that. More testing we do, the better. A testing blitz will occur from January 6th through January 12th, and it will coincide with move-in for dorm residents who will be required again to test negative before moving into their assigned dorm rooms. As with the fall semester, isolation rooms will be provided for those students who test positive. The increased scale of testing will be enabled by a new saline gargle test that Dr. Warby has developed for the university, and you're going to see that momentarily. The test is accurate, affordable, and returns results quickly. Dr. Warby will share more information in a few moments, so stay tuned. Good things coming. I'm optimistic with this new test, which moves us closer to the ideal of a 10-second, 10-cent test. Won't get us all the way there, but we're moving closer. We have the tools needed to, again, mitigate the spread of COVID-19 on our campus and be a responsible member of the Southern Arizona community. These plans are obviously contingent upon the course of the pandemic over the next month. Many of us, Dr. Carmona and myself included, are gravely concerned about local, state, national, even global trends. Dr. Carmona will have more, as usual, to say about this in just a moment. As we all respond now is critical. How we all respond now is critical, particularly with the year-end holidays quickly approaching. And we know it's going to get worse before it gets better. So please follow all of the things that we have said from the start of this. I don't know, Holly, how many of these we've done, but over 25, I think. We're already seeing an uptick in cases and hospitalizations following the Thanksgiving break. Our healthcare system is stretched thin, both in terms of the availability of resources like masks, face coverings, ventilators, and hospital beds. And in terms of the capacity for our healthcare professionals to continue bearing the brunt of the pandemic along with other essential workers. Dr. Carmona has stressed this over and over and over again. We may have beds, we can put up tents and put beds, but if we don't have workers to staff those beds, then they're not going to be of help. And there is a critical burnout effect. Just like we're all burned out on Zoom and we're all burned out on having to stay at home, there are individuals who get up every day and have been getting up every day to go on the front lines into our hospitals to treat these patients and provide compassionate care for the unfortunate people who get the infection with this virus. As we have throughout the pandemic, the university will continue to monitor public health conditions and we will adjust as needed. As Dr. Bhattacharya will discuss the vaccine development process and what we can expect. But remember, we still need to follow public health measures. I kind of botched that a little bit. As Deep is going to explain, we're going to have a vaccine, but we still have to stay on these basic fundamentals. Cover your face, stay as far away from as many people as possible. Sanitize your hands and test. We're months from widespread distribution of the vaccine. Please do not let up now. There's light at the end of the tunnel, but the tunnel is shortening a little bit, but we do have hope and we still need to get through this together. So Holly, I'll give it back to you now.
Thanks, President Robbins. Before I turn it over to you, Dr. Warby, I just want to say that make it clear that we are changing our testing protocols for next semester and moving away from an antigen test to a PCR test for our students. But it is worth noting that we will continue to use the antigen nasal swab testing for our major testing blitzes. So when our students come back at the beginning of the spring for the dorm move-in, we will be doing the 1 hour turnaround of the antigen testing from the nasal swab. But our regularly weekly testing will be the PCR test that Dr. Warby is going to highlight now. So over to you, Dr. Warby.
All right, thanks, Holly. Thanks, President Robbins. Good to be with everybody here this morning. I want to just give you a real brief overview of this test. Most of you will be familiar with this term PCR testing, and it's sort of thought of as the gold standard for how to test for the presence of the virus. And any PCR test, what it does is it tries to find trace amounts of the genetic material of, in this case, the virus, and then amplify that up to a large enough level that you can actually detect yes, no, does this person have the virus or not? The way that has been done, the sort of gold standard has been thought of as this nasopharyngeal swab. So this swab that goes kind of disturbingly deep back into your nose. Not the most pleasant thing, and a bit of a barrier for people to, want to clamor to get in line to do this kind of testing. And a couple months ago, I saw a preprint, so an early report, not peer-reviewed, but still very interesting, from a group up in British Columbia that had been experimenting with what they call a saline gargle. So this is just 5 milliliters of salt water, sterile salt water. And instead of the deep stick in the nose to get back to the pharynx where those cells that are infected are, what this allows you to do is just swish this around and then gargle and get back to those same cells in a much more tolerable way. And they had good results. They found about the same sensitivity as a nasopharyngeal swab, and importantly, they also compared these methods to the saliva test that other universities and institutions are using. And both the saline and the nasopharyngeal swab seem to outperform saliva. So what I did was, with the help of a lot of people around campus, I sampled virus from a lot of students in the isolation dorms and from people coming to campus health who didn't know whether they were infected or not, and just put the nasopharyngeal swab and the saline swab, saline gargle head to head. And, you know, I was hoping for decent results where they were comparable. In our hands, the way we're doing this, it actually pulls virus out of about 30 or 35% more people than when you test with the nasopharyngeal swab. And so I think this is going to become the new gold standard for how to test for this virus. And so at this point, let me just give you a quick demonstration so you get an idea of how easy it is. And I'm going to throw on my mask because one of the nice things about this approach is that you can, first of all, you don't need a healthcare worker exposing themselves and using PPE to take the sample. The person takes their own sample, and that person can wear a mask so that for almost the whole time the sampling's going on, there's no exposure risk. Okay, so we're gonna just take this and twist that top off like you're turning a key really hard. In it goes. Now I'm gonna swish. Gargle. In it goes. Tap it down if it needs to be tapped down until the material's out of the funnel. Funnel screws off. Cap screws on. And there you have your sample. And I'm going to take my mask off now, even though if I was doing this for real, the mask stays on. And in there, again, what we're finding is if we take this material and run it through PCR, this seems to be better than a nasopharyngeal swab. The other nice thing about this is this tube fits in the racks of our clinical testing center. So UAGC, our genomics core run by Ryan Sprisler. And so Ryan and his team and me and my team have been working very hard to come up with the best way to do this. And what we're developing is a way where you can skip one of the costly and time-consuming steps of extracting the genetic material out of this kind of sample prior to amplifying it. And we call that direct PCR. So you just plop this in tube, robot sucks some out, and you go straight into amplifying with PCR. We think we can do about 3,000 of these a day, so you know, upwards of 15,000 a week. And it's comparatively very inexpensive. We think we can get it to below $5. We're aiming for $3. We think that's quite possible. And so again, this isn't going to completely replace the antigen test. It's just another tool, a very high throughput, high capacity, inexpensive, quick, you know, same day for most people, same day result tool that's going to allow us to find more people who are infected and do all of the right things as a campus for those people as individuals and for the population to limit transmission of the virus. And so maybe I will, let me just mention one other thing. When you do this, it's important that you don't eat, drink, chew gum, brush your teeth, chew tobacco, anything by mouth an hour before for the test to work correctly. But I think people, especially now that we're moving to some mandatory testing of large numbers of people, what I know from having done this work is that no one ever asked me if they could do another nasopharyngeal swab because it was so much fun. But people don't mind doing this saline gargle. It's really acceptable. And so we're excited that we have this tool here at the University of Arizona.
And Michael, just to be fair about it, you have to repeat it. You have to do it 3 times, right?
Thank you so much. Yeah, absolutely. So it's a 45-second procedure in total, and I abbreviated it for today's purposes. And when you do it, there is a timer countdown to make it simple to make sure you do the right amount of time.
And the other idea is that we could have kiosks with videos and timers in the lobbies of dorms or buildings, or pop-up kiosks to make it a little easier and hopefully get more people to comply, but not have to go to North Rec or Campus Health.
I would also like to just highlight that any student or employee who wants to participate in this pilot program this week and next can call the testing center at 520-848-4030. So anybody who wants to sign up and want to participate over the next 2 weeks to see what this is like and also get your free PCR testing, please call the testing center, and that information is also available on the website. So I think with that, we can turn it over to Dr. Bhattacharya, who is going to talk to us about the safety and efficacy of our vaccines that are going to be available to us relatively soon.
Sure, thanks, Holly. And can I just put in a little bit of a shout out to Dr. Warby, and I'm certain I would have gagged if I had to do that gargling on camera, so I'm deeply impressed. So what I'd like to do is to go through some of the basic science of the vaccines. I'm sure you've been hearing a lot about them, and some of the details on how FDA trials are normally conducted, and how we managed to get to a vaccine so quickly for this pandemic. So I'd like to start off with what molecular biologists call the central dogma. And so this is looking at just a normal, uninfected cell. And so what the normal anatomy of a cell is that in the nucleus, there's DNA. This is what comprises our genome. This is the sequence of the DNA makes us who we are. And it basically provides the instructions for how cells should operate. The way that happens is that the DNA and parts of the DNA called genes are transcribed into copy or surrogate molecules called RNA. That RNA is then moved out of the nucleus and then translated into proteins that support the functions of the cell. Next slide, please. So the virus is a little bit different in this sense. So the SARS coronavirus 2 virus, the virus that causes the disease COVID-19, once it gets inside the cell, it actually doesn't go through the DNA intermediate like a cell does. Rather, it's what we call an RNA virus. It encodes, its entire genome is encoded by these RNA molecules. So it kind of skips a step in what a cell would normally do. So once it gets into a cell and invades, it releases its RNA into the cell. And then that RNA can then be translated into, we think, somewhere in the vicinity of about 13 to 15 different types of proteins, each of which are required for the virus to make more copies of itself. So this virus is not like a retrovirus like HIV, which then goes backwards from RNA into DNA and integrates into the genome. Okay, so I wanted to deal with some of the things that I've been hearing on social media head on here. The virus does not get into your genome. It just never goes through that intermediate. Now, it seems like a pretty simple life cycle, but as we know, the virus is now a global pandemic, and our best estimates is that, you know, as of today, it's infected there have been over 66 million infections worldwide, over 1.5 million dead, and that count is unfortunately rising. We know that the risk of death is very much highest in the elderly, and depending on how you break down those age categories, it's over 5%, and if you get up into your 80s, it can get up to 15 to 20%. The risk of death in younger folks is certainly less. And so if you take, say, for instance, a 25-year-old, I think our best estimate is about 1 in 10,000. But one of the things I want to raise here is that when you're trying to decide for yourselves what the safest choice is, and in terms of the risks of a vaccine, this is what you're weighing it against. And so a vaccine that would kill 1 in 10,000 people would not be acceptable and would not be approved. And so that's one of the things that I want to emphasize. The other thing is that it's not just about death. The virus, even if you do recover it, can cause prolonged symptoms in something like 15% of people. So this is not a virus that you want to intentionally get. It's really best to be avoided, especially as President Robbins had mentioned at the beginning, given that the vaccines are coming down the road. So let's talk about one of those vaccines now in the next slide. So there are actually 2 vaccines. These are from Moderna and from Pfizer, and they both work in more or less the same way. So I want to take just a little bit of time to focus on how these vaccines work. So as I mentioned in the previous slide, there are a number of different types of proteins that the virus has to make in order to make more copies of itself. The Moderna and the Pfizer vaccines are taking just one part of that RNA, the one that's responsible for making one type of protein, and then gets that into cells using what are called lipid particles. They're basically like fat encoded things that allows the RNA to get inside a cell. So again, it's skipping that DNA intermediate. I've heard some concerns again that the RNA goes backwards and integrates into your DNA, and that does not happen. It doesn't happen with the virus, and these vaccines are just taking one part of that virus to make the new vaccine. Okay, so that's essentially how these Moderna Pfizer vaccines work, and these are, I think, the ones that are the most vetted and are the ones that are likely to hit our communities the soonest. But I did want to briefly go over on the next slide how the other different types of vaccines work. So there's a few other ones that I think we can expect to see on the market at some point in the not too distant future. One of the types of vaccines are made by AstraZeneca and Oxford University, by Janssen, and by Merck. And essentially what they're doing is taking a harmless virus, a type of adenovirus for at least for AstraZeneca and Janssen, and they're making it incapable of replicating and instead dropping in one of the coronavirus genes into the virus so that once that harmless virus gets in, it can't ever get back out, but it does make the RNA that's required to make spike protein. Finally, there are some ones that are also becoming, I think, soon-ish in the next few months or so, that are what we would call more traditional vaccines, and that rather than going through these intermediates, they make the protein directly and then immunize you with that. So those are the different types of vaccines that are going to be coming soon down the road. Now, what I'd like to do is to get into some of the more logistics on how these vaccines get tested in people. Next slide, please. Oh, sorry. I should actually get to this now. And so basically then what happens is that the immune system recognizes these spike proteins as foreign. The immune system is really trained to tell us when things are different. And so it can distinguish between things that are yourself and things that are different. Any immune cell that has the chance of recognizing yourself gets removed during development. And so really, it's just have all of these cells ready to poise to recognize anything that looks a little bit different than yourself. And so when it sees spike protein, this is the part of the coronavirus that the immune system if it sees, can prevent infections. There are different types of cells like B cells that generate antibodies. And there are other types of cells that recognize little parts of the protein that are chopped up inside the cell called T cells. And so the T cells will then kill any virally infected cells should they happen to see anything else in the vicinity or if you actually get infected down the road. And so if you have these antibodies and T cells already, then you have the opportunity of preventing the virus from ever infecting you in the first place, or at the minimum, certainly reducing the symptoms that are caused by that viral infection. Okay, next slide, please. So what I'd like to do is to go through the timeline of what a normal process of vaccine development looks like, and what Operation Warp Speed did to sort of accelerate. Because I know that there's been some concern that the process has been rushed. So I want to make clear what parts of the steps were accelerated, and really, and the short answer is that it wasn't the safety. Okay, so normally during a vaccine development process, there's a long period of basic research and development where you try to understand the virus. What parts of the virus do you need to make an immune response against to protect yourself? Then you go through animal models and preclinical stuff to make sure that it works. Okay, then you go through a shorter phase 1 trial, where you decide on the dose of the vaccine to give to people. You see how well they tolerate it, And you get some early looks to see what the best immune correlates are of that vaccine. And you try to handicap it, is it going to work or not? Then usually what happens is that there's a long period where you try to decide, okay, do we go forward with this or not? Are we going to take a massive financial loss in this or not? Is the pandemic or the epidemic still going to be around by the time we get this thing through? So that takes a lot of time. Then finally you go to the phase 2 and you look at things like, okay, well, you expand up your numbers a little bit on the dose you chose. You try to get a little bit better of a handle on whether there are any safety issues and how the immune responses look in response to the vaccine. Then you take a really long time to decide whether or not you want to go forward with the phase 3, because that's expensive. It takes a lot of resources and effort. And there is always the concern that, again, by the time you have your vaccine, it won't matter and people won't want it anymore. Finally, then you get to the phase 3 vaccine. And then you go through a larger study of usually tens of thousands of people where you're looking for any issues that might happen with safety or with efficacy. Now, I've intentionally drawn the safety line a little bit shorter, simply because for all the vaccines, almost all the vaccines that I can think of, if there are any safety issues that are somewhat rare, they show up in the first 2 to 3 months. So the FDA is really only looking at those first 2 to 3 months. And obviously, if you have longer term data, they'll look at it, but the key phase are those first 2 to 3 months. And then there's the efficacy to see if it actually prevents symptomatic disease or infections. And then finally, at the end of that, you do a lot of more manufacturing and try to get these things out. So what was accelerated here? So first, if we can click on get to the next click here. The R&D preclinical phase was actually not that yet. So R&D preclinical phase was greatly shortened because a lot of these vaccine manufacturers had actually been getting ready after the very first SARS coronavirus back in 2003. So a lot of the framework for making these vaccines and a lot of the basic knowledge of what we needed to do to generate protection was there. Now that epidemic sort of faded out. I think there were only something like 8,000 cases worldwide. And so those vaccines never got rolled out. But that basic knowledge was already there. So then where does Operation Warp Speed come in? So basically these are financial incentives that the governments have put in to eliminate these interim phases where you're trying to decide whether the market will support your product. By pre-committing to buying a lot of these vaccines, you've basically eliminated a lot of these blue phases. So the first market analysis between phase 1 and 2, click please, is basically gone. The market analysis phase between phase 2 and 3 is also basically gone, and then moved down, and manufacturing is being basically done in parallel to phase 2 because the government has de-risked that part of the process. Finally, then at the end, the market analysis and manufacturing is also now being done in parallel with the phase 3. And what you'll see is that the efficacy timeline has been shortened, and I'll explain why in a bit, but the safety timeline has not, okay? So those are the major things I want to do. You can see why, again, this has been shortened by quite a bit. Okay, next slide, please. I know that there have been some concerns that I've seen, again, on social media, that there haven't been long-term studies done on these types of mRNA vaccines like Moderna's. And to a certain extent, that's true. For this particular vaccine, obviously, the pandemic just started in November and December. But when you look at some of the things that have actually already been through clinical trials for Moderna, you can see that they've been around for a few years. And the mRNA vaccines in general have been around, started from in 2013, 2014 by another company called CureVac. So it's not entirely true that this is a completely novel platform and we have no idea what the long-term safety data will look like. It basically looks okay. Next slide, please. One of the things that I want to sort of buffer you against here is that this is going to be the largest scale vaccination campaign that any of us have seen in our lifetimes. And so when we think about these things and safety events, I think one of the things that I really want to caution you against are things that we call anecdotal adverse effect stories. So let's say that in the next month and a half or so, we vaccinate 10 million people. Within those groups of 10 million people, you will start hearing some things. But if you take a group of any 10 million people over the next 2 months, we can expect that there will be about 4,000 heart attacks, 4,000 strokes, 9,500 diagnoses of cancer, 60 new diagnoses of multiple sclerosis, and unfortunately 14,000 will die. And that happens when you look at 10 million people in normal pandemic, in non-pandemic times, whether they've been vaccinated or not. So one of the really important things that we want to keep in mind here is using the data and the numbers to tell us whether there are actually any effects that are coming from the vaccine or not. Anecdote is really not evidence that a vaccine is actually causing something detrimental. Next slide, please. So how do we actually do these phase 3 trials? So what happens is that you randomize a group of somewhere between 30 to 45,000 people equally into arms that either receive a saline or a placebo injection, and the other half that actually get the vaccine. So then those vaccinated and placebo groups are then followed out over the course of months. And over the course of those months, then what is happening is that an independent data safety and monitoring board is recording events of symptomatic COVID-19 infections. And so then, so the company themselves is actually still blinded to these data. So it's people scientists who have no skin in the game that are recording these events. And so at the end of it, then what you're looking for is a total number of symptomatic infections. And then you try to break it down to figure out, okay, how many of those symptomatic infections were in the placebo group? How many of them were in the vaccine group? And in this large cohort of people, were there more adverse events in the vaccine group versus the placebo group? And that's really the only way you can actually tell whether A, the vaccine is working, and B, whether the vaccine is safe. So let's move forward now and talk about some of the vaccines that are closest to being available. And so one of the things that I think us scientists really wanted to emphasize is that we recognize that this is a race to get these vaccines. And in order to build confidence both in us as scientists and then us scientists then communicating that trust out to the public, is that there needs to be very clear transparency in how these vaccines are performing, what the data look like, and just being completely open with what is actually going on. And so what I would say is that the Pfizer and the Moderna vaccines have been outstanding in terms of their transparency and their rigor, in terms of releasing their trial protocols very early, making it very clear what they're looking for, reporting their adverse events, and then at the end of it, giving us a very clear breakdown of what the efficacy looks like. So for the Pfizer vaccine, 162 symptomatic infections were in the placebo arm and only 8 in the vaccine arm. Moderna had very similar numbers. So those are the numbers that we're looking at when we think about efficacies. It's the ratio of those two groups there. And so they have independent monitoring, and I think by all accounts, the adverse events are fairly mild to moderate. Now, they will cause more inflammation than would a flu shot. Your arm will feel sore. You'll get a little bit tired, and you might run a little bit of a low-grade fever. But again, what you're really trying to do is weigh these risks against the actual infection. The AstraZeneca Oxford vaccine, and again, these are my opinions here, but the transparency and rigor so far has been poor. They're not done with their trial yet, and I think they certainly have the ability to correct some of these things. But again, I mean, I think our responsibility as immunologists and as scientists is to call it like we see it. And there's many key details of the AstraZeneca Oxford trial that are a little bit confusing to us. And so we're hoping that they correct those. Okay, next slide. So what I wanted to do, again, just reiterate, how is it that we were able to do this so fast? This is the last slide here. First, the R&D preclinical work, groundwork had already been laid based on the first SARS coronavirus and then another related coronavirus called MERS. The Operation Warp Speed basically eliminated a lot of the financial risks. So these intervening phases between the phases are basically much shortened. The biology of the virus has actually been cooperative to us too. So unlike problem viruses like HIV, which mutate like crazy and you never really generate immunity to, our study from the U of A as well as others have shown that you actually do generate durable immunity once you've cleared this virus. The virus doesn't mutate very rapidly, again, unlike HIV, so it's not very much of a moving target. And then finally, we were able to get to the endpoints quickly, unfortunately, because infections are spreading quickly through the trials. And so they were able to get to their target case number a little bit sooner than they would if the pandemic were under control. Okay, so I'm going to stop there and then turn it back over to Holly. But the summary of how the vaccines work from a science standpoint and from how an FDA trial standpoint works.
Deepta, that was fantastic. Thank you so much. I learned a ton from that. Go ahead, President Robbins.
Yeah, so Dr. Bhattacharya, when can we get vaccine? When will it be in Tucson? When can people start getting these shots?
Yeah, I mean, I think what we're hearing, so the FDA, the formal authorization hearing will be, I believe, on December 10th. And so my understanding is that then the Pfizer vaccine, for the Pfizer vaccine, Moderna will probably be a week after that. And then my understanding is that within a week of that, then those vaccines are going to start getting distributed based on the populations of states and the healthcare workers. So the healthcare workers are going to be first in line for very obvious reasons. And then there's going to be people who are at high risk of disease. And so, the numbers that I've heard have varied a little bit, but, I think what I've heard is that everyone who wants a vaccine could potentially have it by June. And so I'm optimistically hoping that that's the case.
Much faster than I thought was going to happen. Okay.
All right. Well, thank you, Dr. Bhattacharya. That is fascinating. Now we'll turn it over to Dr. Carmona to go through the local COVID numbers and walk us through the expectations over the last 7 days. Go ahead.
Thank you, Holly, and really a great debt of gratitude we owe to Dr. Bhattacharya and Werby for the great work they've done, the teams they've put together, and how they really have pushed the envelope in the science of this. I felt like I was back in graduate school here, sitting in a class, but it was fun to see how much science has advanced. So we'll go ahead and start in just a moment. I just wanted to mention, again, to reemphasize what the president has said repeatedly. In our bubble, we call the U of A and our zip code, we're doing pretty well. I mean, all of the programs that we've put in place, our ICS, all of the teams that support us, the public health advisory team, the immunologists, the clinicians, scientists, all have come together. And, we really have done quite well in managing this challenge. However, as we always point out, we are a small part of a larger population of about 1.1 million people in PIMA County and a larger population of 7.5 million in the state, where people are moving back and forth all the time. And as Bobby has said, we can't let our guard down now, even though some of the numbers you'll see are concerning in the big picture. And for us, they look reasonably okay. Nevertheless, now's the time we really have to tighten up everything we do and adhere to those public health practices. So let's have the first slide, please. So again, if we look at the total cases by day in Arizona and 14-day change, we're up 58%. Deaths have increased nearly 100%, and hospitalizations up 57%. Now, as you know, we've been doing this now for about 7 months, the weekly press conferences, and we track these numbers very carefully. The president gets a report every 24 hours of what's going on, so he can make the best decisions. But what's concerning is, as these numbers go up, you've heard me say repeatedly, there are less and less resources available in the community. We're dealing with the flu season that's coming on top of this pandemic of COVID. We also have the snowbirds who have come out here because the weather's beautiful and they leave cold areas, and they tend to be older and tend to have comorbidities. So we're factoring all of those things in and making sure that we have enough resources in our community. But we are concerned because the numbers are going up quickly. We still haven't seen the full impact of the Thanksgiving holiday. And now we're coming into Christmas and New Year's, where we know once again, people will want to be getting together with their families and friends. We're all suffering from COVID exhaustion. We're social beings. We want to be able to give a hug and a high five and be close to our loved ones and friends. We can't do it. We've got to stay apart, got to wear masks, got to wash hands, got to keep doing all of those things we know work in the public health toolbox, which are the things we keep emphasizing every week. And on top of that, looking at the great work our scientists have done, Dr. Werby, Dr. Bhattacharya, others on a national basis, companies who have vaccines coming to market, and then there are antivirals to look at in the future. So the toolbox we have is what's most important right now to use. And as Dr. Bhattacharya says, we expect probably mid-December, first vaccines will reach us here. But again, this is going to be a multi-month process as we go forward based on a triage criteria, a hierarchy, based on the highest risk people, based on first responders and frontline people getting first, the higher risk people next, and then going down. Teachers are now included because we realize we've got to get our kids back in school because we can never replace the education they get being socially connected in the classroom. So there's a lot of complex things going on, but these numbers here really, really concern President Robbins and I because of the direction that they're going. Next slide. If you look at the curves, we've presented this to you over the last several months. And for a while, we were there pretty happy and flat. But if you look at every other state, you look at the slope of that curve in Arizona, heading up pretty steeply, not as steep as other states, but nevertheless, still significant increase that tell us we have problems. Next slide. You see here the COVID PIMA County cases, the numbers at the top there, but you can see the spike there. And it's probably worth mentioning here as well, and I think the reporters media may want to ask questions too, but we're still concerned with the conspiracy theorists. We're concerned with those who are the vaccine deniers, the mask deniers, people who make comments, it's just the flu, don't worry. Not so. This is a potentially deadly disease. It is not common flu. It is more transmissible. It can kill you. And if not you, a loved one, if you're indiscriminate with your activities. We're all in this together. So of course, we must continue to mask up, stay socially distanced, and make sure we follow all of the public health guidelines. And for those who don't believe, look at the numbers. Look at the numbers. Look at the people around you. Look at the hospitals that are filled, the beds that are filled. We don't see this type of impact on the health community with the common flu. Next slide. This is the transmissibility RT that we talk about all the time. And as I often mention, we were quite proud for a long time being well below the threshold for active transmissibility. We're up. We're not as bad as other places, but we're still not happy that it's at 1.18. We want to get it down below that. Pima County's 1.16. The zip code 85719, we actually are really happy about, and that's because we've worked hard with the county and the city and the zip code that surrounds the U of A, where at one point we were at 2.58, I think it was. Now we're at 0.82, which is below 1, which says the transmissibility is lower. These numbers on a given day don't tell you a lot. It's the trend that we're watching and what we're seeing. We've been able to hold pretty well in that zip code around us at the University of Arizona with no evidence of transmission in the classroom, but we can't be complacent just because we have a small bubble that we're looking at that looks good. We are part of a bigger ecosystem that is struggling, and our people go in and out of that ecosystem every day. They go home, they see their families, they go shopping, they go to the store, they eat. Got to be real careful. Next slide. So these are the incidents we talk about every week in CART deployment. Overall, we're down 0.4. We still have a few. It should be also emphasized here that under the president's direction, in the beginning, we tried to inspire people to do the right thing. We asked them not to aggregate and have big parties or meet in fraternities or sororities or off-campus housing or in dorms because you could spread infection, and that sometimes half the people around you are asymptomatic. And people didn't listen for a while. We saw spikes. We saw large groups, as many of over 100 at times. The good news here is people are starting to listen. I think a lot of it is because we've inspired them. They've seen the adverse outcomes, but also that the president had authorized the dean of students to take action, disciplinary action, when people fail to comply. Because failure to comply is not just a nuisance. You are being a vector potentially for spreading disease which can kill others. And that is unacceptable. So the numbers are good. The numbers have improved over time because of our good public health messaging and the dean of students being very actively involved, identifying those folks who decide not to comply. And in some cases, expulsions or other disciplinary action have occurred. And I think that sends a strong message that the president and the leadership team are very, very much engaged here and will not accept unacceptable behaviors. Next slide. So if we look at the testing results, which we've done fairly well here, you can see in the most recent time, we've had 144 tests and there's no positives. In the last 10 days, we're at 2.1% with over 6,000 tests and 130 positives. And that's pretty good because as we said throughout the last 7 or so months we've been speaking with you, the goal is to stay below 5%, as much below we can. But these are decent numbers, but we're still going to work hard to push them down. Total testing window since August, you can see we've done nearly 94,000 tests, and there's been just under 3,000 positives at a 3.1%, which is pretty good. Again, that's our bubble in the bigger bubble of our county. And that's why we continue to work very closely with the city, with the county, with the elected officials, with Dr. Cullen, with Mayor Romero. Working together, we've been able to achieve these good results that show that as a team, we've been effective. Next slide. So total number of tests and positivities by day. The good news there, if you look at our tests, the tests are still perking along pretty well. As the president said, we're doing everything we can to increase testing and different types of testing. We are working aggressively toward that aspiration of a 10-minute, 10-cent test. And we're getting closer with some of the work you've just heard today from our scientists. But nevertheless, our testing continues. The amount of positivity is still fairly low, which is we're happy about with the degree of testing we're doing. But we're still going to be we'll still be imperfect until we can get up to a point where we test everybody every day. Because those gaps of a few days in between or a week in between, you can also become positive and we won't know it. And you could be an unwitting vector and spread disease. So we're getting better at the science. It'll come faster, it'll come cheaper. And at some point we'll have our Wildcat app that will be integrated with a daily test that can be self-administered, that will be reported, and you'll have a green check mark. And then we'll know that you're safe to go any place on campus or in town. Next slide. So thank you again for coming back every week with us. And again, the greatest shout out to Dr. Werby and their team, Dr. Bhattacharya, for all the great work they have done on behalf not only of the University of Arizona, but really the work they're doing is work that is needed nationally and globally. Holly, back to you. Thank you.
Thanks, Dr. Carmona. It is 10:53, so I'm going to just head straight into the questions. We've got a number of them in the lineup. And the first one comes from Megan McNeil from KOLD. She says, are there possibilities of requiring students to get the COVID-19 vaccine next fall before returning to campus?
Yeah, I can take that one. We certainly, we went through this about having discussions with our shared governance partners. There was some talk about mandating just garden annual influenza vaccine for all of us who have privileges in hospitals. You must get a flu shot before you can go and care for patients. And I was a big proponent of doing that. It turns out regulatorily, administratively, trying to keep up with that turned out to be not warranted because of, as Dr. Carmona said, the low incidence of influenza this year. So we passed on that. I would like to see us mandate that we all get this vaccine in order to come on campus. Now, that has to be with some caveats. Have to get approval from our attorneys. And with all of these, as Dr. Carmona emphasized, there is a large group of people who just will refuse to take the vaccine for whatever reason. And so we'll have to go through a well thought out and an intentional exception policy for medical exceptions, religious exceptions, and things like that. I would very much like to see this be required for everyone who works and who comes to the campus as a student.
So she has a follow-up, and that's, is there any push or advocacy to get students or professors higher on the list for the vaccines?
Yeah, maybe I'll ask Rich to comment on that. I'm not sure. You know more about the hierarchy of of who will get prioritized. I think, as Deepta said, frontline healthcare workers, certainly our most vulnerable populations will most likely get this vaccine first, and those would be people of certain age, maybe nursing home residents, people who have known chronic health conditions. But Rich, you have any more ideas about that?
I think you're spot on as usual, Bobby. I'll just add that, as you know, we've discussed this over the last many weeks in anticipation that this would come up. And obviously the first responders will come to mind, those people on the front line. But then there's nuances. We have people say, well, only those people who are essential. Well, that word is a tough one, because the pilot who flies the plane, who brings those vaccines to you, is an essential person, because if he's not there, all the science doesn't work. The truck driver who brings you the vaccines to whatever the point of inoculation, same thing. So these are discussions that have been going along. National academies have had some opinions. White House has put out something, as has CDC. I think the newer issue that came out was we need to do everything we can to immunize our teachers, especially elementary school teachers, so that our children can get back in school. Because the loss of the interpersonal relationships and learning just how to act, not only education, is very, very challenging by doing it in a distance and having a kid on a laptop. So that's important. Here we've also talked about, what about our scientists like Dr. Werby, like Dr. Bhattacharya, who are working with virus every day in their laboratories. So there are exceptions that we have to look at, of people who have unique risks because they're risking themselves to serve us. But overall, I think how you framed it, Bobby, is exactly how the nation is looking at this.
It's also worth noting that the governor did put educators on his executive order as on the list of the first people to receive the vaccine. So our next question sort of sidetracks us, but we'll get right back to the COVID questions, is from Rocio from KJazz. And he wants to know, he wants to ask of the university for a comment on the analysis by Grand Canyon Institute, which says that the U of A has not committed to financial investment to turn around Ashford's poor academic and student services.
Yeah, I would say that there is clearly a comprehensive, well thought out plan for investment in improving the quality of course delivery, retention, and completion for the University of Arizona Global Campus students. I also would highlight it's a separate freestanding university that has its own president, faculty, board of directors, and that the University of Arizona has an affiliation agreement with this new university, which is a not-for-profit university. So we feel very confident that there will be investment in the success of those students, just like we invest in the success of our students.
Our next question comes from Chris Conover from AZPM. Go ahead, Chris.
Good morning, everyone. Just actually probably a quick follow-up. The testing mandate for students coming on campus, will that apply in the spring? Will that apply to faculty and staff also who will be on campus in the spring?
Yeah, I will let Rich and Holly comment on that. My understanding is that it would apply to both students, faculty, and staff. There's a little nuance in the faculty and staff, but in general, yes.
Yes, I think, again, Bobby's spot on as usual. That is the discussion that's going on. And even anybody visiting on campus, because anybody is a potential vector. So we have vendors that come to campus. We have salespeople and so on. So we're looking at even more broadly, making sure that everybody who comes on campus and interacts has appropriate screening.
Great. The next question comes from Stephanie Casanova from Arizona Daily Star. And she says, President Robbins, you said testing would be required for students attending on-campus classes and living in the dorms. But you said anybody else looking to come to campus will be expected to have been tested within a week. Does this mean it won't be mandatory for that group? And can you explain how the university can track that?
Yeah, well, as I outlined in my opening statement, for students, we know how to track our students, and we're using the Wi-Fi access as an incentive for them to comply with testing. It gets a little trickier, obviously, for people coming on campus. For instance, we would love for you to come on campus and visit our bookstore. It's open. But we don't know if individuals who come to the bookstore, for instance, have been tested or not. So it gets a little bit difficult to figure out everybody who comes on campus. Of course, the bookstore is operating and very safe, appropriately distanced, requiring face coverings to come in and things like that. Moreover, there are plenty of people from the neighborhood. We've got a beautiful campus that they come on to either run or walk their dogs or ride a bike or whatever. So, you know, the enormity of compliance and tracking this is really difficult, and obviously we can't assure that everybody has been tested. But for our students, faculty, and staff, we do have mechanisms to be able to track them.
Yep.
And I think we have one final question, and it comes from Kagan from Ciara. She wants to know, does the U of A anticipate having in-person orientations this summer with widespread vaccine distribution by June? And if so, will testing be required?
Yeah, that's a good one. I know that Casey and her team have had a lot of interest in not just next fall, but the spring semester. So I think that it's going to be difficult to have in-person tours, but I'm confident that we could do some limited in-person touring. But I think we would want to have make sure that those individuals were tested. So my sense is that there won't be a lot of that. It'll still be virtual, and that's been fairly successful. I would just point out to how many students have chosen to come to the U of A, and the uptick in numbers that are interested in the spring semester. And with this great news that Deepta has given us about the availability of vaccines, hoping that we can get back to a more normal fall term is very exciting.
Yeah, the COVID working group is actually looking at that currently, and it's all based upon what the situation looks like as we get closer to the spring and into the summer. So definitely worth noting that is definitely under consideration in our working groups, but it all is dependent on what happens over the next several months. And then those recommendations go directly to the ICS and directly to the president for consideration.
Yeah, Holly, I would just say that I think that Dr. Carmona has made it abundantly clear. In early January, we're not going to be having any tours because we're expecting there to be continued increase in incidence and prevalence of this deadly disease in our community. So I think the data would show that inside, as Rich has said, our bubble, the spread of the virus has been very, very limited. But we live in a larger community. So I think we can all expect this is going to get worse before it gets better. And the vaccine couldn't come at a better time than now. And I'm just hoping that, that our national government is going to have the ability to not only have the manufacturing done by the companies, but then to transport and then administer these shots. We're going to be part of working with the county because I think deep to a couple of, at least the Pfizer vaccine requires -80 freezers. And as I've said before, I'm trying to think of the county I grew up in. I'm not sure where I would find a -80 degree freezer in the whole county. And we've got many of those counties here in Arizona. So we'll be working. My understanding is the vaccine will come through the county and then will be distributed out from the county to Banner Health, TMC, the university, other places.
I think you're right. Well, it concludes all of the questions we have today. So thank you for taking your time. Thank you, Dr. Bhattacharya and Dr. Warraby. Those were unbelievable demonstrations and explanations, and really goes to the heart of some of the questions that we receive here on a daily basis. So thank you for joining us today. And with that, President Robbins, you want to end it with your usual?
Yeah, I will to give the admonition for being safe out there. This is our last session before returning in January, and I hope everyone is safe and has a joyous break. But I do want to again thank Dr. Bhattacharya and Dr. Warby for their incredible work. I get to hang out with them most days between 3 and 4 in the afternoon to listen to all the science and to strategize about how we can be most effective in mitigating this virus. And of course, daily with Dr. Carmona and the ICS team. We meet weekly with our public health advisory team. And I'm just continue to be impressed with how everyone who have full-time jobs have been able to pivot and to parallel process and focus so much on the collective effort to try to fight this pandemic and keep the University of Arizona moving forward so that our students can continue to pursue their education, get the classes they need, the credits they need, to be able to move on, many of whom graduate, go to graduate school, or get a job. Also for our researchers, and you've seen both Michael and Deep to show you that research is alive and well at the University of Arizona, and not only just surviving, but thriving and really leading the world in some of these key areas. We haven't talked about Dr. Pepper in weeks, but the wastewater-based epidemiology continues to go forward. So I couldn't be prouder of the University of Arizona and what we're doing to help make this as safe as we possibly can and to continue the mission of the university. So with that, I'll just ask everyone just to remember, continue to reach down deeply, bear down, and mask up.